Okay, everybody, welcome to introducing SDL Perl. Before I get started, I'll let you guys know that this is probably going to end up being more than one talk, just because I'm barely scratching the surface tonight. And, well, depending on how much time I have, because this is kind of rather time-consuming to learn, but also very fun and interesting. And let's see, basically, we'll get started with what is SDL. SDL is basically a it's called a simple direct media layer, and basically it gives you things like video playback, audio, keyboard, mouse, joystick input, and obviously 2 and 3D graphics. The 3D graphics is actually provided via OpenGL, but basically you can use it through SDL. And what's nice about that is, as far as I understand, and again, I'm not an OpenGL expert, but just from what I read, I believe that it doesn't provide for all the other input things. So you can use it through SDL, get your 3D graphics plus all of your input events. Okay, I think we covered most of that, except for it's also cross-platform, and it's a whole ton of platforms, so I didn't even list them, because it's every major one you can think of, plus a whole bunch of them you might have a hard time remembering. And it also has bindings to a lot of different programming languages, you know, C, C++, Perl, Python, I think Ruby, anyways, a lot of them. This is my joke slide. Sorry, I couldn't resist. If you don't know what Perl is, you're probably in the wrong you're in the wrong building. Okay. What is SDL Perl? Obviously, SDL Perl is the Perl bindings to SDL. Now, these have actually been kicking around for quite a few years, but I don't remember why, but I know the initial developer ended up kind of abandoning it, and it just sat around for a while collecting dust on CPAN until some guys resurrected it and actually started improving it quite a bit. And so they've made quite a bit of progress just in the last couple of years. So you've got the website here, which they've actually got a user's manual for beginners that they've got started, which was very handy for me in putting this presentation together. IRC, mailing list, you know, all the good stuff you can think of. And I think they've really done a good job with picking up the project and moving it forward. So basically, you've got 2 different layers here. You've got the SDL layer, which has a whole bunch of classes in it. That's the low-level stuff that's binding, you know, pretty much directly into the SDL library. And then you've got the SDLX layer, which they're adding on, which gives you a lot of nice abstractions. So less worrying about bits and rectangles and things on the screen, and more worrying about like sprites and animations, and you know, it basically makes your life a lot easier. They add a lot of sugar on top that just prevents you from having to worry about all the little details. So I wanted to show you too, recently they had a contest, 4-week contest, where they just had people, you know, build a game in a week. And then here you go. This is what I made in a week. So I'm not going to go through all of them because there's a lot of them, but I thought it would be a good thing to look at. Whoops, didn't want to do that. Just to get an idea of the types of things you can do. This one was like a clone of Space War. So, ooh, The graphics look terrible on that, but anyway. I'm sure you can all tell what that is. I won't bother maximizing it since it freaks it out. So, Asteroids clone. And then, let's see, the rest of those are kind of originals. And then I wanted to, okay, we got Wheel of Fortune here. Somebody did in a week. Obviously, Snake. That one's a pretty obvious one. Somebody probably would have done Pong, except that's actually in the manual, so that one was kind of already taken. So, actually, no, which was kind of surprising. Bubble Breaker game. Here's kind of a directing traffic game. This was supposed to be a Crossfire clone, but I actually ran this one and it didn't look finished to me, but they at least had gotten started on it. This is one the author made for his friend Sue. I thought it was pretty funny. He put in a little anecdote that he made it for her birthday, and she has a terrible habit of not looking both ways when she crosses traffic. So anyways, it's a Frogger clone, but called Saving Sue. So I thought that was pretty amusing. And I did try to get several of these running, and on my system didn't have any problems. So this one, Electric Lines, this one was actually deceptively, it looks easier than it actually is, because you think, oh yeah, I just do the lines and I, direct it over to, you want to not hit the red ones and hit the green ones. But what I didn't realize was it doesn't just follow the first thing that it hits, it'll follow every node that it hits. So you actually end up with, a line that helps you in one case, but then later on in the game it screws you up because it ends up sending other ones to places you don't want to go. So you're constantly drawing other lines to redirect them back to where you want to go. So that one was actually pretty fun. Played that one for a while. This was, basically a dance clone. Actually, I don't know whether or not they got it hooked up to a dance mat or not, but it, works with the arrow keys, so it wouldn't be that much work to get it to work on that. Yep. And last but definitely not least, this game has been around for a few years. I don't know if any of you have seen it before, but it's called Frozen Bubble. And this, as far as I know, was the first big game of its kind written in Perl. So, in fact, actually, I think they did this with the old version of SDL. So, but as you can tell, it's got great sound, great graphics. I'll just get into it for a little bit. Nobody wants to see me play for an hour, but just so you get an idea of what type of game it is. You can see at the bottom what the next color is coming up. And basically, if you hit, you have to have at least 3 to hit, and then they fall. And obviously, like if you hit like blue up here, the red ones down here will fall too. So anyways. And also the thing comes down. If you wait long enough, when you get to the higher levels, it comes down. Okay, that's enough of that. Again, the point of all that was just to give you an idea that you can actually do real games with this. Yeah. Okay, now I'll just talk a little bit about installing it. I don't know if any of you are familiar with the Alien namespace, but that's a namespace they've come up with to basically package up alien things to Perl. Like SDL is something that's outside of Perl. So by doing this, what it does is it gives you several different options. It can if you've already got SDL on your system, it can detect and you can pick to use that, or you can build it from source or certain subset of all the different, because there are several different things. There's like the audio, there's the text, there's the video, that sort of thing. So you can pick and choose which things you want to build from source. I just did the all for obvious reasons. I think it usually says recommended. But what's nice about that is, you know, you should be getting a version of libraries that's going to work with the version of the module, the SDL Perl module, because it just pulls it all in, compiles it all for you, and off you go. So. And yeah, as usual with other CPAN libraries, it'll pull in whatever dependencies you need and stuff like that, so you don't have to worry about it. So you just install Alien SDL and it pulls in everything else you need. Okay, we'll talk now, since we've seen a few of the games, and you'll see I've got some examples that we'll get into with the actual code. But basically everything is drawn on a surface of some sort. And when you create basically the main level screen is just called a screen, but it's actually a subclass of surface as well. So you can draw directly on the screen, or you can draw on other surfaces and then copy and that sort of thing. You can do all sorts of different kind of things. And if you've done anything ever on almost any system that I've ever run into, it's got, you know, upper left-hand corner is X0, Y0. So it's basically up here is 0 and, you know, positive that way, positive this way. So it's inverted from algebra that you learned where it's positive down. But that's fairly typical of pretty much every graphics thing that I've seen. Okay, now we'll actually start to look at some code. I'll just open this up. Is that good enough for everyone to see? Okay, good. And then we'll just actually run it here real quick. Okay. All this is very basic. Just a screen, loads up, black, not very interesting, stays up for a few seconds. But now we'll look at the code. So to do that much, doesn't take a lot of code here, you know, got the usual stuff here, use SDL, SDLX app, which means basically the app is giving you higher level functions so that you don't have to worry about every little thing. So you just create a new app, call update on it. Basically the update is to update the screen. I'm not doing anything interesting here, but the main reason I've got it here is according to the docs, not all systems will default to a black background. So if you want to make sure that it will, you should always run update, because some of them may be transparent or a different color on different systems. And then I'm just sleeping for 5 seconds and it goes away. So again, not very interesting, but I'm just going to build this up piece by piece into something that is a little more interesting. Okay. All right. Oops. Okay, now you notice we've got Hello World up there. So again, not terribly interesting, but at least doing a little more with it. Okay, you notice what's different this time is that now with the app, we're actually passing it some parameters. So instead of just getting a default size screen, whatever size that is, I give it a width and height, I give it a title for the title bar, do an update, and a sleep. Again, not terribly interesting, but there you go. Any questions so far? Okay, because we're starting to get into a lot more interesting stuff. Okay. Is that good? Okay. Okay. Now this is just kind of a sample of graphics primitives. Primitives are just basically what are the things that are built in that I can draw with this. So you've got text. Some of you guys may even kind of recognize this font. It's kind of ripped off from Diablo, but actually it's a free version that is ripped off of, that was ripped off from Diablo. But anyways, we've got a line, circle, rectangle, circle. You notice this one is translucent. So you've got alpha, which we'll talk about when we look at the code. You also notice this thing just didn't go away after I, ran it like the other ones did for 5 seconds. Because this one actually takes input. So if I hit Q, it's gone. If I hit the X up here, it's gone. So now we'll talk about how all that works. Okay, you'll notice a few new modules up here. We've got SDL event, which handles the events, like the clicking of the close or hitting of the Q button. We've got app, which we've seen before, and we've got text, now that we're actually dealing with text. So I made it the window a little bigger, just so I'd have room for stuff. Width, height. Also, before I didn't have depth, it does by default, the default color depth is 32 bits, so but I just put it here so you could explicitly see it. If you wanted something lower, I don't know why you would, but if you wanted something lower, you could make it lower. Yeah, exactly, if you really wanted to go retro. Again, title. So, all right, now we're actually getting to the good stuff. Okay, so we create a new SDLX text object. Here's the font, which is just a normal true type font that I just copied into the local directory for convenience, so that, for one, actually originally, I should back up. When I was originally going to do this talk, I actually started developing it under Windows. But I kind of ran into some problems, so this is full disclosure here. I didn't get everything to work quite as well as I wanted to. I wanted to be able to run everything in Windows and in Linux, same identical files both ways. So that's why I put the TrueType font in the directory, so I didn't have to worry about paths being different on each different system and stuff like that. Hopefully, maybe the next iteration or the next version of the talk that I do on this, maybe I can actually get that working. But I just ran into certain things that didn't seem to be working very well under Windows. Obviously, though, since I showed you that the frozen bubble plays fine on Linux and Windows, there are ways around this stuff. I just didn't have enough time to figure it all out. Okay, so back to the text object. We basically just have an anonymous array here, 255, 255, 255. That's why we have white text, as you would probably expect. It's just RGB, red, green, blue. So you can vary those according to what you want. Just a point size, 72. Just pick that because it's somewhat standard and large enough to read. X and Y, so I basically started it at the top, 0, 0. But I modified it with a horizontal line of center. And so that's why it's at the top of the screen, center, even though my X value is 0. It still ends up centering it because I modify that. Okay, then we take, and to actually put it on the screen, we take message, call the write to method on it. The first parameter is the surface that you're writing to. In this case, it's the actual screen. In real game cases, maybe not, maybe a different surface. And then just the text that I want it to write, hello world. There's also a way, and this is one of those things I actually wanted to see if I could track down the bug. You can specify the text when you create the new, but again, I actually would bomb out with an error, so I thought maybe I'd try to contribute something to the project, and at some point when I get time, I'm going to look into that. Although, for all I know, maybe in the Git latest cutting-edge version, maybe they've already fixed it. But that was something I ran into as well. So here's our line. We've got our X and Y coordinates start, X and Y coordinates end, and then again our colors. There's our alpha on the end, and this is yellow because we've got red, green all the way to 255, and blue is all the way to 0. And then it's completely opaque with the 255 for alpha. So here's the next thing. This is the circle that was on the left-hand side that was obscured halfway by the rectangle. So we draw a circle filled. This is the center of the circle. This is the radius, I believe. Yes, the radius is 50. And then again, the colors, RGB and alpha on the end. Okay, here, I'm just setting up, making it a little easier on myself. I'm just basically doing all these in slightly different ways, just so you can see all the different ways that you can do these things. So I'm setting up some variables, putting them into a rectangle array, just so that I don't have to have just raw numbers. It makes the code a little easier to read. So we'll actually look at this. So now I can just call draw rect with rectangle, which is this anonymous array with my coordinates, my width and height, and the rectangle color, which again is right here. And that was a red rectangle, if you recall, because that's all. We got 255 on red and 0 on everything else, and it's fully opaque. Okay, now just to show you, there are other ways of doing it. You can actually specify, like you would see in HTML with hex values. So again, 0, 0, FF, that's a blue circle. And you notice the 80 here, that's basically set at half transparency, if I remember right, what I set it at. So that's why you get the translucent effect over the other rectangle, is the alpha is now different. So again, you can either specify it as decimal numbers or hexadecimal number, however you want to do it. It just figures it out and takes either one. Okay, now we'll talk a little bit about the events. I just set up one handler, add event handler, to the app, and it's just called quit handler, because that's all I'm doing is enabling you to quit. So, and then you notice here at the end, run. This gives you your basic loop, or it just sits there and loops forever. And if it were a real game, it would be checking things like, did I get input, or updating positions of things on screen, or checking for collisions, that sort of thing. But, once you hit run, it just goes into the loop and just starts processing, all the input, all the output, that sort of thing.
So that's just in that main area then?
Yes, exactly. This is pretty much the end of main here.
Anything
up is all just main.
What the loop is going to do?
Yes, exactly.
Now, is there a way to specify different thing than that, or is it?
I'm guessing that there is, because I've seen people actually use. I noticed on some of the games from the contest had dependencies on other event-driven loop modules that I was kind of familiar with. Haven't looked into that too much yet, but my guess is yes, that there are other ways of doing it. Okay, so let's look at the quit handler. Basically, the first two things that it gets passed are the actual event itself and the controller. And the controller is just another high-level object that allows you to do, control a bunch of things about the application. Again, next time I do a talk on this, I'll get a little deeper into what all these different things do. But for right now, I'm going to skim over a few of the more complicated things. Okay, so basically, we're looking for, we've got a constant that was exported for us, so that you don't have to have a number there. You can actually look at something that's readable. So it's looking for SDL key down on the type of event. it's also got a key up, so you could look for that instead if you wanted, you know, to check on the release of the key rather than on the press of the key. You could do that. Obviously, for this, it doesn't matter, we're quitting, but for other applications, it might. You might care the difference between pressing and releasing a button. So here is how we actually get the name out of the key, because basically it's got an integer value that just represents the actual key that you hit. So, but we want something that's a little easier to work with, so we're going to get the key name. So I'm also checking for another type of SDL quit. SDL quit means you hit the X and you killed it. So that's basically what it's looking for, is the operating system telling it, hey, you're done. Or if my key name is Q, then it calls stop on the controller, which actually stops the whole application. So that's basically, this is pretty much kind of the bare minimum of what you would need to get started on a game. You know, obviously we don't have anything moving around yet, but at least you've got all the concepts here. You've got the event handlers, and you've got your game loop. Any questions there before I go on? Okay. All right. Now, I alluded to earlier, you know, multiple surfaces, so now we're going to actually look at that a little bit. Okay, this is basically just obviously not the best graphics you've ever seen in the world. And I also have to give credit to the guys. I directly stole this from the manual. So some of these I wrote myself. The first three you saw I wrote myself. This one I just decided I might as well take theirs, because why reinvent the wheel? Because it did a good job of illustrating the principles. So it's just basically blue sky. If you see the darker green back there, basically it's drawing, you know, kind of grassy area. And then you've got a whole bunch of flowers in front, basically. And you notice how when I hit the Q key again, I did take their code and modify it somewhat, because I wanted to, I can't remember whether or not they had the quitting handler or not, but I wanted it in there. So I did take their code and kind of tweak it a little bit. So you notice here, the one new thing we've got here is SDLX Sprite. Basically, a sprite is, especially maybe it's easier to illustrate with old school games, you know, like if you've got a little Mario running around, that would be considered a sprite. And so basically it's just, in here, it's a surface that you can draw on that's not the main screen. So you can, and we'll see in a little bit what we do with that. Okay, so I won't belabor this too much. We've seen all this before. Only thing I changed was the title and made it a little bigger. Okay, again, we've got a quit handler, so still not much going on event-wise. So we draw a rectangle for the blue sky. And I'm not going to go through all the parameters again unless somebody has a question, because they're basically what we've seen before. Draw the green field. Okay, now is the new and interesting stuff. So now we create a flower out of an SDLX sprite. So we give it a width and a height. It's basically just a rectangle. There's no X and Y because it just exists out there in memory. It doesn't actually exist anywhere on the screen. It just is a rectangle, okay? So now what we do is we start to draw on that surface. So we say flower, surface, draw, rectangle. And then basically you notice we've got 50 and 100, which match our width and height. And if I were doing a real game, I would have put those in variables. So if you decide you want to change the size, you don't have to change it in 20 different places. But and then here we made it basically black and completely transparent, because the alpha is set to 0. And you notice, I'll bring the flowers up again, but you notice that the flowers, you don't see any black rectangle around each flower. You actually only see the flower, because when it renders those, the background is completely transparent. So you can see all the flowers and or the field or the sky in the part that doesn't have a flower drawn on it. Okay, so we've got the transparent background. Now we just draw a rectangle for the stem. Nothing too exciting, it's green. And, you know, they picked reasonable size for it. And then you notice that they draw two circles, one filled and one that's the outline, because I don't know if you guys noticed, but they were actually slightly different colors. And then here's the fun part. Just have a for loop here. We pick a random X, which we adjust, and we pick a random Y, which we just adjust so that we're constraining it to that area of the screen that we want. And then we say flower, draw XY. We pass it the app, which remember, that's the screen, and the X and Y. So now there is an X and Y associated with it. So we're taking, basically, you can think of that one sprite, and we're stamping it all over the screen. So, you know, now you've got that sprite, which is a, you know, a certain object, and now you can copy it or, you know, paste it all over the screen or, you know, do a bunch of different things with it. So we update the screen and we do our run loop. And then, you know, I'm not going to go through the quit handler again because I think it's identical. Yes, it is. So this is no different than the other one was. Just checks, did you click it to close it or did you hit Q? Any questions so far? Okay. Okay. Now, we'll talk a little bit about animation because that's the thing that makes games interesting. Well, basically, with animation, you've kind of got an issue in that, you know, back in the day, there were so few types of computers, and there was a certain clock speed, right? So game developers kind of knew what they were getting into. You know, the hardware was a lot more standardized than it is now, at least as far as the processor. You knew there was only a certain kind of processor, and it only went this fast. Okay, so then, and also most people were like on DOS. So, you know, it's not like it's a multitasking system. The only thing it's doing is running your game, you know, and whatever DOS interrupts and things are in the background. So you guys may remember the good old turbo button. What was so amusing about the turbo button is it actually wasn't meant to make your computer go faster. It was meant to make it go slower, because it would cut the clock speed in half so that you could play older games that would run like crazy on your newer hardware. And again, newer meaning still ridiculously old nowadays. So I don't know if you guys remember the turbo button, but yes. Yeah, that's actually what it was for. And of course, the marketing guys go, oh, turbo, but that's not actually the point. The point was actually to make it go slower so that you could run things that were locked to the CPU. What's that?
It doesn't work it well.
Yeah, exactly. You don't want the snail button or the turtle button. So they say, call it turbo. Also, though, nowadays, more what the issue is, you've got all kinds of different clock speeds. You've got all kinds of different processors. You've got multi-cores. You've got, you know, multitasking OSs. I mean, actually, this laptop's powerful enough that I can have this VirtualBox running Ubuntu on it, have Firefox running, and play a game, and it, you know, doesn't even choke on it. It does just fine. But obviously your game doesn't have the full attention of your computer. It's got, you know, Firefox doing Firefoxy things, and maybe it's reloading pages if they've got auto refresh, but it's definitely consuming memory, and VirtualBox doing its thing. So you've got a lot of things going on that the game developer has no control over. You know, they don't know exactly what kind of hardware you have or how fast it is or what else you might be running at the time same time that you're running the game. So one of the possible solutions is to fix your frames per second so that it's locked to a certain value you pick, like, excuse me, maybe 30 frames per second, 60 frames per second, 75, just depending on some of it you want to match your screen refresh rate so that you don't get tearing and stuff like that. But again, that's just the maximum. That's just, you know, you're setting it at a certain value, and if the computer can't hack it, guess what? You're not going to get that value of frames per second. It's going to start dropping frames, and everything's going to get real jerky. For really fast computers, guess what? You're wasting a bunch of cycles sitting there just waiting so that you can spit out the next frame, because it's just sitting there going, and you know, it's like, well, I can't put another frame out yet because my frame rate is fixed. I can only put out 60 per second, and so it just sits around and waits until it's time to put out the next frame. So this is not necessarily the best solution. One of the other solutions, which is, as you would guess, since it's a better solution, it's a more complicated solution. That's usually the way things go, is to utilize physics. So what you want to do is tie your frames to actual clock time rather than computer cycles, because time is the same for everybody, unless, of course, you want to get into relativity and you're sending your computer playing a game off at close to the speed of light. But hey, if you're there, it's still going to look like it's going the same speed for you, so that doesn't matter. Basically, I won't even click this link, but I included it. If you want a really detailed explanation of how this stuff actually works, you should read this article. I'm not going to go into all the nitty-gritty details of exactly how all this stuff works, just because, again, this is an introductory talk. But we will look at some actual code that does animation. And again, this is not perfect either, because the animation I've got is still a little jerky, because there are some things you can do to sort of blur frames or to add extra frames or fewer frames depending on what's going on. Again, since this is introductory, I didn't want to make it quite so complicated. The next talk probably will be diving into some of those details. And not to mention, I have to learn a lot of those details because I'm relatively new to this. I've only been working with this for about the past month or month and a half. Okay, so there we go. Pew pew. Laser shooting. So you notice it's a little jerky, but it is moving across the screen. Part of it might also be due to the fact that I'm running this within a virtual machine too, instead of on the actual system, but that'll just sit there and run forever. So let's look at the code. Okay, large enough for everybody? Actually, I must have already had this file open in a larger one. Okay, again, this is all the stuff we're used to. We're actually not even using a sprite here, whereas if it were a real game, you probably would. But I think this is, again, one that I stole from the book and then kind of tweaked myself. I think the point, though, was to illustrate the physics, not the sprite blitting and all of that junk. So they actually took it down, made it simple, and it's just a rectangle. It's just drawing a rectangle. So we'll get into that in a little bit. So basically, none of this is very interesting except for laser equals 0, because that's where it's going to start, and a velocity, which I can tweak this if I want. Actually, the book had it at 10, but I made the screen bigger, so I increased it to 20, because otherwise it's kind of boring watching it slowly go across the screen. So, and again, the only event handler we have is the quit handler, so we'll skip talking about that again. All right, but now you notice we've got new handlers that we hadn't discussed before. We've got a move handler, which calls calculate laser, So this, as you might imagine, calculates the position of the laser. And then you've got a show handler, which is the thing that controls how it displays on the screen and when. So, and then again, app run, that hits our loop. So as soon as we hit that, we're off and running, and it just sits in loops, and it checks for events now. It calls the move handler, and it calls the show handler as it's going through the loop. Again, we'll skip the quit handler because that's identical. I did kind of paste this in from the manual just so that if anybody's downloading this and looking at it, it at least has got a brief explanation of what's going on. So it talks about consistent velocity. Again, it's not accelerating, so this is kind of a simple model. It's just going at a constant speed across the screen. Because actually that's what I wanted to do, was do kind of something cool that accelerates across the screen, but I realized it would really balloon the talk and all the different concepts that I'd have to discuss. So I was trying to keep it simple just to focus on the basics. So you've got a velocity times your time step, and then you've got a constant y value, right? Because it's just moving across the screen. So your x is changing, your y is staying constant. So it just moves horizontally. And then it just gives you a bunch of numeric examples. So if you had 10, which again it was originally, it'll go through these coordinates. The first time it'll be 1 or 0, 100, 10, 100, 20, 30, by tens on down. This obviously staying fixed. And so now the speed of processing the loop doesn't matter anymore, because now you're actually connecting it to real time that's passing, and we'll see that here in a second how that actually works. Okay, so for the handler calculate laser, basically it gets past the step, and that's the difference in time calculated for the next jump. Again, we're talking about actual time now. And then we've got the app so that we know what surface we're dealing with here. And then we've got T. So basically now we just say laser plus velocity times step, because again, you remember from physics, it's basically that's what gives you your speed. It's a vector. And then laser equals 0 if laser is greater than the width of the app. That's why it keeps starting back at the other side of the screen. When it reaches the far side of the screen, it starts back over at this side of the screen. Any questions so far? Make sense so far? Okay, good. All right. Okay, this is the part that I was talking about. The delta can be used to render blurred frames, which that's not implemented here at all. This is just kind of noted that we're being passed a delta so that we can use it, and that's basically a time difference. Again, the app, and then now we're basically drawing black over the background, and you notice that we're actually clobbering the whole screen, which you'd never do in a real game because it's way too expensive to do, to black out the whole screen. You basically black out only as much as you need, or actually you wouldn't even black it out. You would like copy over the background or do something of that nature. And then we draw the laser, which, again, basically it's picking the y value of half of the height of the screen, so it just puts it right in the middle. And then you call update, and update is what refreshes the screen again, because remember, this is the show handler, so this is the thing that actually shows it. So it takes the new calculations that are done up here, and then it does the drawing down here on the screen. So anyway, any other questions at all? Okay, yeah.
Is all the games that you've seen the code for basically single-threaded, or does it have a multi-threaded capability?
That's a good question. I don't know the answer to that, because a lot of it's going to depend on whether or not SDL is multi-threaded or not, and actually that I don't know. So far I haven't seen any multiple threads, but then again, like I said, I've only been working with this long enough to come up with this presentation, and I hope maybe next time I'll be able to answer questions like that and know a lot more about it. But I'll try to keep that in mind and maybe post it to the mailing list and check that out. So that's basically it for now. So next time, I hope to, do a little more interesting animation. Actually have maybe something you can control on the screen, maybe some sound effects, who knows. I've got some ideas for actually some games that I'd like to build. Game programming is incredibly time-consuming, though, and I also have no artistic ability, so I'm reliant on the nice artists on the internet that put up their sprites and graphics for free. So you can find different resources. Actually, off of the SDL website, SDL Perl website, I believe that they do have a link in there somewhere that has like free artwork that you can get for your game, because that's a problem that a lot of people wanting to write their own game have is, a lot of them are talented at one or the other. They're either really artistic and not terribly technical, or really technical and not terribly artistic. You do have the occasional prodigies that can do both, which is great, but I'm not one of those because I have zero artistic ability. So anyway, any other questions before we finish up?
There was a spot in the one where you drew all the flowers.
Uh-huh, yeah.
You had to draw, or you did draw black background, completely transparent.
Yes.
Drawing the flower. Why?
Oh, let me rerun it, and then I'll show you the code.
I'm sure there's a reason to just...
Okay. The reason is, if we want to illustrate it, is pretend there's a black, this flower right here, black background around it. That wouldn't look very pretty when you're drawing all of these, and you've got a black rectangle around it.
Why did you have to do that line at all? Why did you have to do that line? Oh, because that's the default.
But yeah, because the default is it's not going to be transparent background. So I had to force it to be transparent so that when it was drawn, you could see what was behind it. Because every single one of those, even though they don't look like it, they look like they're a complex geometry, but they're all actually rectangles.
The sprites have default values.
Yes. Yeah. So by default, well, and I shouldn't say for sure that I know what the default is, but it may be one of those things that's system dependent. So you definitely want to set it to what you want. Yeah, exactly. So you're good. We don't need to look at the code again. Okay.
The animation one, and you were mentioning that you didn't draw the acceleration because you were worried about going into...
Well, talking about a lot of more complex. Sure.
And scroll down to the where it draws across the screen, or it moves across the screen.
Okay. Well, here is the calculation of it. Yeah. Uh-huh.
I guess. So if you wanted to accelerate it, couldn't you speed it up for every... How would you know what frame was? So,
Well...
because you can tell to slow it back down once it hits the far right, because you can calculate...
Sure, yeah. But basically you would want to increase the velocity every time that it calculates it. Well, that's the thing is, the step is going to matter. It's going to be dependent on, how fast the computer it's running on. Because again, now we're talking about time. And again, one of the things I wanted to do, but I didn't get a chance to do, was actually put up a display of frames per second. Because on different computers, you'd actually get a different value. Some you may get a ridiculously high value of, like 200 frames per second or 150 frames per second.
So because you're going in steps, would that actually cause it to move faster, or just render faster?
It would move faster. It would move faster because you're changing the velocity. That means every move is going to be further than the one before.
It's based on frames per second, not time.
No, time. The other way around. It's based on time, not frames per second. So this actually, the way it is, let's forget acceleration for a second. Constant velocity, exactly. That's why. It's because it gets more confusing when you get into it. Yes. Well, basically, the way it's written, will run on any decently modern processor at the same speed. So if we put, one of these guys' laptop right next to mine, ran them both, they would both go the same speed. And that's what you're trying to accomplish. Is because I'm sure if any of you guys have ever played the old school DOS games and stuff like that on any kind of a modern processor, it's ridiculous. You can't even play it because they move so fast. But again, that was back when they were used to. We know we've got the full processor at hand, and we know how fast it goes. Go for it.
What do you think theoretically would be involved in writing that then?
Well, I
calculations?
actually probably don't want to speculate on that since I haven't done it yet. So, no. Well, you'll be...
Because you were creative going at the time. I wanted you to stop.
Well, no, I didn't, because actually, yeah.
Wouldn't it
Well,
be something like you'd read the time before at the start of the game and the middle, and then maybe calibrate from when you get from one end of the screen to the other.
Well, all of these are great ideas, but to tell you the truth, since I haven't done it yet, there's no point in, because I may completely mislead you because I haven't done it yet. So that's the next steps, yeah. And I'm fully, have no problem with saying I don't know the answer, and I don't, because I've literally just learned enough to do this talk, and that's how much I learned. And so hopefully for the next talk, I'll know a lot more. Yeah. Yeah, it's incredible the things you can do with Perl. I mean, I fell in love with WX when I ran into that, WX widgets, because you can do GUIs in Perl. And I mean, they work great. They work, and they use the native widgets, cross-platform. And I have written cross-platforms with that. I'm getting off topic now. But anyways, now that I'm on it, with WX widgets, where I literally copied the same file from Linux to Windows, and it runs on both systems, but it looks like Windows in Windows, and it looks like Linux in Linux. Oh, yeah, and this is a little trick that I think I told Tom, but you other guys may not know, is actually Perl on Windows will read Unix line ending files. So you can literally make a copy of it, and it will run just fine. Now, the opposite is not true. Perl will blow up all over the place if you have Windows line endings on Unix, because they've got the stupid 2-character line endings. So apparently all Perl actually cares about, well, again, you could put all your stuff on one line. I mean, you've seen ridiculous obfuscated programs, right, where they put it as long as you've got white space in the right space. So Perl apparently only cares about the line feed, not the carriage return, and that's why the Windows version will actually run. So that's what I actually do with my cross-platform stuff, is I always just make it Unix line endings, and then I can copy it anywhere, and it just works without modifying it. So.
DOS to Unix or whatever.
Oh yeah, yeah. In fact, Vim has a real easy way of converting line endings. So I could if I wanted to, but it's
why bother?
Well, and it's bragging rights. So it's more fun to say I literally copied this from one system to another, and it works completely unmodified. I didn't even have to change line endings, and it works. So. Also, probably sometime I've been meaning to talk about PAR, which will probably come in along with this, because that's a way of packaging up applications and distributing those. That I have used before. It's been several years since I've used it, but I actually had built one of the WX widgets applications at my last job, and I actually had a Windows installer and used PAR to package it up, and said here, just gave them the exe, they double click on it, it installs, puts an app icon on the desktop, just like any, and nobody would be any the wiser that it's actually running Perl.
That's crazy.
They would have no idea, because PAR will actually load up all the libraries, the DLLs, whatever it needs. So it's cheating a little bit. It's not actually creating an executable. It's just pulling in everything it needs, a mini Perl environment to take with it so that it can run on the system it needs to. So again, if you've got games, that's a perfect target for something you want to distribute to people and make it easy, because not everybody, especially on Windows, most people are not going to have Perl on their systems. So anyway, okay, I went completely off topic, so I guess we could stop. All right, thanks for coming, guys.
Thanks,